Hello and welcome to the ONNX Operators SIG presentation. This is Rama. In the first half of the presentation, I will cover changes and updates since the previous release. These changes are expected in the ONNX 1.9 release due in a couple of weeks. In the second half of the presentation, I will talk about some upcoming action items. The changes to the ONNX operator set 14 are fairly modest. There are two new ops, a try-low operator for a lower upper triangular matrix op, and hard switch, which is a activation function defined as a function. Several of the existing ops have been extended. Recurrent operations have been extended to support batch major layout. Reshape has been extended to allow 0 as a valid value in that dimension of a shape. Many other ops are being extended to support lower precision types, both integer types as well as float. Batch norm is being extended to support training mode. Let me now describe some extensions to the function definition infrastructure. As you may know, ONNX ops defined as functions can be expanded into a subgraph of simpler, more primitive ops. This makes it easier for backends to support such ops even when they don't have a direct implementation of the op. And in particular, ONNX permits context-dependent functions, and these are functions where the constructed function body depends on statically available context information. This context information includes the number of actual inputs and outputs specified in a particular call, as well as the values of attributes specified in that particular call. Now the context information is being extended to also include the types of inputs. And at this point, let me briefly point you to one issue, which is sort of a more forward-looking work item. This is issue 3139. And when we define a function, we really need to think about the target offset we use to define the function body. And how we deal with this when offsets are changed and updated requires some thought. So your opinion and feedback on the issue would be most welcome. Among other changes, a language syntax and parser has been introduced for ONNX. This is still an experimental feature. Among other things, this will help us simplify function definitions. The examples shown in this page, as well as the next two slides, come from the function definition of the range function. As you can see, the parser lets us replace tedious protobuf-based coding, and if you consider this is the existing function definition, and the hope is we will replace that by something that looks like this. And the benefit is that we will get more readable and easy to maintain function definitions. Now, switching to the second part of the presentation, let's discuss some things we would like to address going forward. There are a couple of proposals for ONNX type system extensions. One is to introduce a sparse tensor type. There's a PR out there, and your feedback and comments on the PR would be much appreciated. One of the design questions for us to consider in this context is whether the sparse tensor format should be part of the type system or not. So for example, if you look at implementations out there, there are multiple sparse tensor formats such as COO, CSR, block sparse, and so on. And the second type extension is to introduce an optional type constructor. So we can, for example, have inputs that are optional tensors. This is a fairly straightforward proposal and should be an easy change. And so one of the action items going forward is to reduce the number of primitive ops and replace as many ops as possible by functions. So another action item we would like to work on is to unify the interface style used in the ops in the specification to enforce uniformity. For example, one change which has already been done, but as an illustration, is the way access values are specified and handled, and in particular for the use of negative values as a numpy. And the final item here really belongs more to the architecture and infrastructure SIG. And the idea here is to propose a uniform style for reference implementation of ops. So thanks again for coming, and please get involved with the operator SIG. There's a Slack channel where you can discuss the operators, and there's a monthly SIG meetings. Please do join these meetings for more in-depth discussions on the various issues. And of course, finally, there's GitHub itself. Thank you.